Hello, good morning students. See, welcome back to our e-learning session. And it is initiated by Vidyadis Vidya Sankul under the guidance of Dr. G. M. Sutaria sir. See, in our last lecture, we complete the theory point 2.3 binomial probability distribution, all the theory and the property of Bernoulli trials as well as the properties of binomial distribution. And now we will discuss our practical sums, that is illustration number 11. Okay, so first of all I am reading the sum. Illustration number 11. There are 3% defective items in the items produced by a factory. See, I told you in my first lecture, that is what we have to find out, that is what is the probability of success and what is the probability of failure, that we have to discuss from the question. See, the controversy I told you in my last lecture is here. The point is first of all, see the controversy whichever is given into the question, I want to explain you right now first. Okay, 3% defective item is given into the question. So first of all, two parts are there, defective items and non-defective items. Defective, if we want to say that defective item is a probability of success, then here the probability of failure is non-defective item, right? Word is important, please concentrate on the word, because here the controversy is only given into the word, nothing else. So please concentrate on the word. Defective item is the probability of success if the last line of the question, what is the last line of the question, here we have to concentrate on it. Okay, but the difference between defective and non-defective and the word not defective, see, the difference between these two words is most important here. Non-defective and will not be defective. Will not be any defective. We have to just see the difference between these two. Why? The controversy is here. Defective word and non-defective. If we are consider that defective is a probability of success, then we can say non-defective is a probability of failure. Okay, but here it is true only on the basis of the last line, or you can say the main question of the main part of the question, that is the last line. See the last line of this question, what is the probability that there will not be any defective item. See, any defective item, it is not said that non-defective item. If defective word, both the word is same here, then you can say this is the probability of success and this is the probability of failure. So you can say this one is the Q and this one is the P. See, again, if the question says that what is the probability that it will not be any. see here, this is the X, this is the not probability of success, this is the not word of probability of success or failure, this is the word for the X. Here we have to see 3 points, P, Q and X. Okay, P means what? Probability of success. Q means what? Probability of failure. And X means what? Whatever variable we have to find out, that is your X. Here this word is contain X. Defective, only the word defective we have to see that. If here the non-defective word is used, non-defective, then this is your probability of success, and then now this one is the probability of failure. So here the small but the confusing controversy is given here, we have to concentrate compulsory on it. Okay, so afterwards 11, 12, 13, after all the examples we'll discuss this point and we'll clear about this. But for this sum, please concentrate that here what is the question first. There are 3% defective items is given. So 3% defective item, and the last line, what is the probability that there will not be any, the last point, defective item. What is defective item? That's why your probability of success in this case, in this sum, is defective items. So now see that I am writing the answer. Illustration number 11. First of all, probability of success is equal to defective item is equal to P is equal to 3%. That's why 0.03. Now probability of failure is equal to non-defective items, that is Q, and if Q is not given, then the formula to find out probability of failure is equal to 1 minus P, that is 1 minus 0.03, that is 0.97. So Q is equal to 0.97 and P is equal to 0.03. But what is the question? Now the question is, probability that there will not be any defective items, therefore X is equal to 0. No defective item means 0, right? Not be any defective item, that is X is equal to 0. Now we want to find out the probability of X, and the formula for that is NCX into P raised to X into Q raised to N minus X. This is the binomial distribution formula, right? And here X is equal to, where X is equal to 0, 1, 2, up to what? Up to N. N is equal to what here? N is equal to, see that I am reading the questions now full. There are 3% defective items in a items produced by the factory. So defective item 3%, probability of success is 3%, that's why 0.03, and the probability of failure, that's why 1 minus P, that is 0.97. 4 items are selected at random, that's why your N is equal to 4, right? N is equal to 4 here. 4 items are selected at random. That's why n is equal to 4 from the items produced. And what is the probability that there will be not be any defective items, that is x is equal to 0. We have to find out. This is the formula and we have to find out just x is equal to 0. That means here we can write that P of x is equal to 0 is equal to P of 0 is equal to n is equal to what? 4c. X is equal to what? 0 into P is equal to what? 0.03 raised to x. X is equal to what? Again 0 into Q is equal to what? 0.97 raised to n. N is equal to 4 minus 0, 4 minus x. Okay, very easy. Please, first of all, you have to apply this formula to find out the probability of binomial distribution. P of x is equal to ncx into p raised to x into q raised to n minus x. Here 4 items are selected randomly, that means n is equal to 4, right? N is equal to 4, x is equal to 0. Why? Because not any defective item, that means 0 defective item, that means x is equal to 0. So P of x is equal to 0 is equal to P of 0 is equal to n, that is 4c x. X is equal to 0, 4c 0 into P is equal to 0.03 raised to x is equal to 0 into q raised to n minus x. Q is equal to 0.97 raised to 4 minus 0. Just put the value, nothing else. Now find out 4c0. Always nc0 is equal to n. This is the shortcut. Whatever nc0 is equal to 1. This is the shortcut I told you in the probability chapter. So nc0 is equal to 1. That's why here 4c0 is equal to 1. Again, any raised to 0 is equal to 1. Any constant amount raised to 0 is equal to 1. That is a raised to 0 is equal to 1. That means here 0.03 raised to 0 is equal to also 1. nc0 1. A raised to 0 1. So here 4c0 is equal to 1 into 0.03 raised to 0 is equal to 1. So here now only 0.97 raised to 4 and find out the value. 0.97 into is equal to right, 3 times is equal to, sorry. So the answer is 0.8853. This is the answer, and please write down the line. Thus the probability of getting no defective item in the selected 4 item is 0.8853. Okay, I hope you understand this. Please write down first of all. This is your answer. Please write down this. Now, I hope you complete that. Now, illustration number 12. The probability that a person living in a city, see now the controversy again, is non-vegetarian is 0.20. Whatever the probability is given, first of all concentrate on it and then see the last line. whatever the question, main question is there, it contains the same, that means it's a probability of success. If it contains the opposite, then it means it's a probability of failure. Whatever the given is probability of success or probability of failure, that we have to first confirm and then we can write the answer. Okay, I hope you complete this. Now see that. See, I am reading first question, then we will discuss about the answer. The probability that a person living in a city is a non-vegetarian is 0.20. Probability of non-vegetarian person is 0.20. Okay. Find the probability of that at the most 2%, n is equal to 2. At the most 2%, x is equal to, x less than or equal to or greater than equal to, at the most, whatever at the most and at least, two words are there. Whenever the at the most word is there, we have to use at less than or equal to, and whenever the at least, we have to use the greater than or equal to. So please write down the shortcut also. At the most, we have to write down less than or equal to. At least, we have to write down greater than or equal to. This is the shortcut. At the most, less than or equal to, at least, greater than or equal to. We have to use that particular sign. Okay. What is the probability at the most 2? X is equal to 2. Here, person out of 6 persons. So n is equal to 6 person. Total persons, n is equal to 6, and at the most 2 persons, therefore x less than or equal to 2. Total persons, n is equal to 6%, and at the most 2%, that means what? X less than or equal to 2. At the most, less than. At least, greater than. Okay. So at the most, less than or equal to 2. Okay. Now, what is the probability of success and what is the probability of failure? That we have to confirm from the last line of the question. What is the last line? 6% randomly selected from the city is non-vegetarian. The word non-vegetarian is given here in the last line, as well as in the question probability of non-vegetarian is given, that is 0.20. Non-vegetarian in the first part, non-vegetarian in the last question. So last question is main confirm. That means here non-vegetarian is the probability of success. So here the probability of success is equal to non-vegetarian persons is equal to P and is equal to 0.20 is given. Probability of success is equal to non-vegetarian persons. Why? How we confirm that it's a probability of success? In the last line of the question, that is main question, non-vegetarian persons probability we have to find out, and that's why it's a non-vegetarian persons is a probability of success, and that is given 0.20. So now the probability of failure is vegetarian persons is equal to Q and is equal to 1 minus P is equal to 1 minus 0.20. So Q is equal to 0.80. P is equal to 0.20, Q is equal to 0.80, N is equal to 6, and what we have to find out, that is the probability at the most 2%, that means X less than or equal to 2. What means of that? At most 2% means 0, 1 or 2. Up to 2% we have to find out the probability, but we have to find out the probability of 0 or 1 or 2. At the most means what? Less than 2. Less than 2, 0 is included here, 1 is included, as well as 2 is included here. That's why or is added, sign of this plus. Here in the probability chapter, whenever or word is there, we have to add it, and whenever the and word is there, we have to multiply it. That we already seen in the first chapter of probability. That's why here that rule is also applied here. Probability law of addition is applied here. So whatever less than 2 means what? 0, 1 and 2. That means 0 or 1 or 2. We have to add this. Probability of P of X less than or equal to 2 is equal to P of 0 plus P of 1 plus P of 2. NCX, P of X is equal to, this is the formula, but we want what? Probability of X less than or equal to 2 means what? P of 0 plus 1 plus 2. Up to this we want to find out the probability. Now what is the probability of 0? We have to apply 0 here plus 1 here and 2 here. So I am writing from here, therefore P of X is equal to 0 plus P of X is equal to 1 plus P of X is equal to 2. Therefore C0 into P is equal to what? 0.20 raised to 0 into 0.80 raised to 6 minus 0. This is P of X is equal to 0. P of X is equal to 0 is equal to NCX 6C0 into P raised to 0. P is equal to 0.20 raised to 0 into Q raised to N minus X. Q is equal to 0.80 raised to 6 minus 0. So here only P of 0. Now P of 1. 6C1 into 0.20 raised to 1 into 0.80 raised to 6 minus 1. Just follow this formula. NCX 6C1 P raised to X 0.20 raised to 1, because we are finding out this one, and Q raised to N minus X. Q is equal to 0.80 raised to 6 minus 1 plus 6C2 into 0.20 raised to 2 into 0.80 raised to 6 minus 2. So I hope you understand this. First of all, we have to write down probability of success, then probability of failure, then N is equal to what? Total person 6. From that, what we have to find out the probability? At the most 2, that means X less than or equal to 2. Here this is the formula, but here P of X less than or equal to 2 means 0 plus 1 plus 2. So here 0 plus 1 plus 2 is equal to this plus this plus this. Okay, so this is the P of 0 plus P of 1 plus P of 2. Now again 6C0, that is NC0, 1, 0.20 raised to 0, again 1, 0.8 raised to 6. Plus 6C1, 6 into, see, NC0 is equal to 1, but NC1 is equal to N. This is the shortcut I told you in probability chapter. I hope you all remember that. Please remember, because these three chapters are interlinked, first, second and third. Okay, so here this is the shortcut we already discussed in probability chapter. NC0, 6C0, 1, 0.20 raised to 0, 1 and 0.8 raised to 6 as it is, plus 6C1 is equal to 6, 0.20 raised to 1, again 0.20 and into 0.8 raised to 5 plus 6C2. We have to find out that particular amount. 6C2, that is 6 into 5 upon 2 into 1. This is again a shortcut. NCX is equal to N into the amount. See, 6C2, that's why we have to multiply just two amounts, 6 into 5, and in the denominator 2 into 1. 0.20 raised to 2, that is 0.04. Directly I am written that, and 0.80 raised to 4. I am just writing 20 raised to 2. Okay, so here again 1 and this one is the 0.8 raised to 6. Okay, then plus 6C1 6, 0.20 raised to 1 0.20 and 0.80 raised to 6 minus 1, that is 0.80 raised to 5, plus again 6C2, 6 into 5 divided by 2 into 1, 0.20 raised to 2 into 0.80 raised to 6 minus 2. Okay, so now simplify it. 0.8 raised to 6, it's 0.2621 plus 6 into this into 0.8 raised to 5. First of all, find out 0.8 raised to 5 in your calci. Then multiply the answer with 0.20 and then multiply the answer with 6. Find out in your calci what is the calculation. Here I am writing out 6 into 0.20 into 0.3277 plus 2 3s are, that's why 15 into 0.04 into 0.4096. See, 0.8 raised to 6, 0.2621 plus 6 into 0.20 into 0.8 raised to 5, 0.3277 plus, here the simplify is 15, simplification is 15 into 0.2 raised to 22, that is 0.04 and 0.8 raised to 4, that is 0.4096. Now the multiplication and addition, 0.2621 plus 0.3932 plus 0.2458 is equal to the final answer 0.9011. This is your final answer, 0.9011. So the calculation is somehow difficult. Whenever at least or at the most word is given, at the most less than or equal to 2, at least greater than or equal to 2. At the most means 2 or less than all the amount. So x will start from 0. So 0 plus 1 plus 2. At the most 2, that means less than 2 all the amount. Less than 2 all the amount, that is starting from 0, 1 and 2. So 0 plus 1 plus 2. Now put the value of x is equal to 0, put the value of x is equal to 1 and put the value of x is equal to 2 into this formula. In this formula, x is equal to 0, 6c0 into 0.20 raised to 0 into 0.80 raised to 6 minus 0. This is the first. NC2, that is NC1, that is 6C1 into 0.20 raised to 1 into 0.80 raised to 6 minus 1. That is the second part, and plus 6C2 into 0.20 raised to 2 into 0.80 raised to 6 minus 2. That is the final part. Now simplify it, and your final answer is 0.9011. See, the calculation is somehow difficult, so please concentrate in these sums. Otherwise, it is very easy. You have to just make a practice. I told you in my probability chapter, that is also here you have to just make a practice of each and every practical subject 2 or 3 times minimum. Otherwise, it is very difficult to remember all the points, all the calculations of these practical subjects. So please do the practice once or 2 times these sums, that is illustration number 11 and 12 in your rough book. 2 to 3 times compulsory. Please do the practice. In your fair book, you have to just write down illustration number directly. See, government cancel your syllabus from 1 to 10 examples. That is point number 2.2. And now directly we are starting illustration number 11. So now 11 to 21 or 22, all the illustrations are most important. It will ask in 3 to 4 marks. Okay, so please do these sums very carefully, very easy sums, but you have to make a practice for this sum 2 to 3 times. Okay, then it will be very easy for you. So please write down this illustration in your example book, as well as practice 2 to 3 times in your rough book. I hope you complete this. Now we move forward to our next illustration, that is illustration number 13. And if you are not complete this, then please pause the video and write down the sum. Illustration number 13. The mean and the variance of the binomial distribution are 3.9 and 2.73. Now the probability of success, probability of failure is not there. The mean and variance is given here. Variance of binomial distribution is equal to n into p into q. This is the formula of variance, and it is given 2.73, and the mean of a binomial distribution is equal to n into p, and it is given 3.9. See, first of all, the variance. See, mean is given. Mean and variance of the binomial distribution, not specifically said that, but we have to say that respectively means what? First is mean and the second means a variance. Okay, so here mean is equal to what? N into p. That is the, we have to see the properties of binomial distribution. In that, in the last session we see that the mean of binomial distribution is equal to n into p, and that is the mean is given 3.9 in this sum, and the variance of binomial distribution is equal to n into p into q, and that is given 2.73 into this sum. Find the number of Bernoulli trials, Bernoulli trials conducted in this distribution and write p of x. That means here we have to first find out the Bernoulli trials, number of Bernoulli trials, that is n. Okay, find out the number of Bernoulli trials conducted in distribution and write P of x. We have to find out these two, that is first of all n and then P of x. Okay, so here n, p and q, all the items is not given. First of all we have to find out n, then we can find out p, then we can find out q. No, on the basis of this information we can find out directly q, and on the basis of that we can find out p, and on the basis of that lastly we can find out n. Okay, so here for the formula given, a q is equal to variance upon mean is equal to npq upon np is equal to npq is equal to 2.73 divided by np is equal to 3.9. So the value of q is 2.73 divided by 3.9 is equal to 0.7. Find out this divided by this from your in your calci. 2.73 divided by 3.9, therefore q is equal to 0.7. Now first is we find out the first, that is q. Now p is equal to what? 1 minus q, that is 1 minus 0.7, that is 0.3. Therefore p is equal to 0.3. We find out first q, that is 0.7, then p is equal to 0.3. Now n, here n is equal to mean upon p, that is n into p upon p is equal to np is equal to what? 3.9 divided by p is equal to 0.3. Therefore we can say n is equal to 13. See, just put the value. Q is equal to what? Variance upon mean, npq upon np. npq is equal to 2.73, np is equal to 3.9. Divide it, find out q, that is 0.7. 0.7 we have to put in this formula. 1 minus q, 1 minus 0.7, that is 0.3. So p is equal to 0.3. And n is equal to mean upon p, mean is equal to np upon p, p cancel, that's why n is equal to, np is equal to 3.9, p is equal to 0.3. So here n is equal to, we can say n is equal to 13. So your first question answer, find out the number of Bernoulli trials. Here is there, write down that answer, particular answer. Thus the number of Bernoulli trials conducted in this distribution is 13. 13, right? Write down this. Thus the number of Bernoulli trials conducted in this distribution is 13. N is equal to 13. And what we have to find out? P of x. Now for P of x we have all the things. What is the formula for P of x? P of x is equal to ncx into p raised to x into q raised to n minus x. Formula for P of x is equal to what? In the binomial distribution, ncx into p raised to x into q raised to n minus x, where n is equal to what? 13, p is equal to 0.3, q is equal to 0.7. Just find out the P of x. X don't know, where we can write here, where x is equal to 0, 1, 2, 3, 4, dash 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 13 up to n. So x is equal to 0 to 13. But what is the value of P of x now? Therefore P of x is equal to, n is equal to what? 13. So 13cx into x we don't know, so that's why we have to just write down the x. Okay, so x, p raised to x, p is equal to 0.3 raised to x into 0.7 raised to 13 minus x. X we don't know, that's why in the question, or you can say in the formula, we just have to write x as it is, and we know, that's why 13c x, p raised to x, 0.3 raised to x, q 0.7 raised to 13 minus x. This is the last or final answer. Or here again we have to write down that where x is equal to 0, 1, 2, dash 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 13, because n is equal to what? 13. So x is equal to, formula is there, where x is equal to, not here we have to write down, here we have to write down 0, 1, 2, dash 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 n, and here this is the formula and this is your answer. What is p of x? See, n is equal to 13, p is equal to 0.3, q is equal to 0.7. In the distribution, it is p of x can be written as follows. So p of x can be written as follows. This is the formula and this is your answer. We just have to find out p of x, not the value of x is given. We just put the value of n, p and q into the formula and find out p of x. And p of x is here 13cx into 0.3 raised to x into 0.7 raised to x. This is your answer. Two questions. Find out Bernoulli trials, number of Bernoulli trials, that is n is equal to 13, and find out p of x. This is the answer of p of x. Very easy, and it is compulsory a 2-mark sum, short sums, which we'll ask in section C. Okay, so it's very easy and it is also important one. So please write down these. See, n, p and q. I told you that n, p is the parameters of binomial distribution in our last session. Okay, so here the question will ask differently. Here they ask number of Bernoulli trials, that is n. If they find out the parameters of binomial distribution, that means you have to find out n and p. Okay, so whenever the question change, you have to give the same procedure, but the answer is n and p. If the question is not like that, that is you have to find out the number of Bernoulli trials, but the question is that find out the parameters of binomial distribution, then we have to find out this way, from this way, n and p. Okay, so here now time for homework. Exercise 2, section C. Question number 8. Nine. Section D. Question number 8. Okay, complete. This is the homework for today's lecture. Please write down all these sums in your exercise book and all these sums in your example book, and I hope you all make a practice of these sums in your rough book 2 to 3 times also. Okay, so here I am complete my lecture. So thank you class, have a nice day, bye bye.